Hello, Math 1060 class. Let's do part C of that final exam review. Number 1, a pair of dice is rolled. What is the probability of rolling a sum of 11? Alright. So let's just list all the possible ways we can get an 11. It could either be 5 or 6 or 6, 5. I think those are the only two ways. And we know there are 36 possible outcomes when we roll 2 dice, so that reduces to 1 over 18. What are the odds against rolling a sum of 11? That's part B. Well, you could do this using probabilities. The odds against rolling a sum of 11 is the probability of not getting an 11 divided by the probability of getting an 11. And we just said the probability of getting an 11 is 1 over 18. That means 17 over 18 is the probability of not getting an 11. So if you take the ratio of those two probabilities, it looks like 17 to 1. And that is multiple choice. One card is randomly selected from a standard 52 card deck. What is the probability of drawing a queen? That sounds easy. Well, there are 4 queens in the deck out of a total of 52. That reduces to 1 out of 13. What are the odds against drawing a queen? Part B. Well, once again, you can just take a ratio of two probabilities. It's the probability of not getting a queen divided by the probability of getting a queen. And we know the probability of getting a queen is 1 out of 13. Well, that means 12 out of 13. And yeah, I just subtracted 1 out of 13 from 1 to get 12 divided by 13. So those 13s cancel out. It's 12 to 1. We are flipping 3 coins. Outcomes in the sample space are represented by strings of H's and T's. How many elements are in the sample space? Part A. Use a slot diagram. Each coin has 2 possible outcomes. Sounds like there are 8 elements in the sample space. Express the event there are more heads than tails as a set. So if there are more H's than T's, there are 2 cases to consider. We might have 3 H's or we might have 2 H's. So I'm going to list all the possible outcomes for 3 H's. Well, obviously there's just 1. How many ways can we get 2 H's? Well, if you have 2 H's, there must just be 1 T. So the T could come at the beginning, could come in the middle, or it could come at the end. So it looks like it's that event. The probability that there are more heads than tails. That's really just the probability of the event that we just listed. So notice that there are 4 things in that event. And we said earlier there are a total of 8 things in the sample space. So the probability is 1/2 that you have more heads than tails. The probability that there are an equal number of heads and tails. Well, we only have strings of 3. So there's absolutely no way for there to be an equal number of T's and H's. So the probability of that is 0. The answer is just 0 for part D. You have 3 of those letters. There's no way exactly half of them could be H's. 3 is not divisible by 2. If the odds against event E are 1 to 19, what is the probability of E? Okay, so I guess we could use a Venn diagram on this one. The odds against E are 1 to 19. That means there's one thing outside of E and 19 things inside of E, outcomes. So if I'm looking for the probability of E, well, there are 19 things in E and a total of 20 things in the sample space. So 19 out of 20. What is the probability of getting either a spade or a jack when you draw a single card? So remember to use the union symbol for the word or, and we have to use that probability rule. Make sure you remember it for the final exam. So there's the union rule. So how many spades are in the deck? Well, 13 out of 52, because a spade is a suit. How many jacks are in the deck? 4 out of 52. A jack is a rank. How many cards are spades and jacks at the same time? Just one, the jack of spades. So that reduces to 16 out of 52, 8 out of 26, or 4 out of 13. The windshield wipers on a car have not been working properly. The probability the car needs a new motor is 0.55. The probability the car needs a new switch is 0.35. And the probability the car needs both is 0.25. And both means motor and switch. Notice the intersection is used with and. What is the probability the car needs neither a new motor nor a new switch? Well, that is the complement of one or the other. So it's better to find the probability that it needs one or the other first and then subtract it from 1. So let's use the union rule again. So that's the probability that it needs one or the other. The probability that it needs neither one is the complement of that. 0.35. Subtracted from 1. And in this one they give us a little picture. And all of these discs are also colored. And let me see. It looks like this one is yellow. This one is yellow. This one is yellow. This one is yellow. This one is pink. This one is blue. This one is pink. This one is blue. And this is blue and pink. So let's see what they're asking us to find. Find the probability that it's a heart given that it's yellow. So remember, just focus on the yellow ones. That's the sample space. So here's a yellow, here's a yellow, here's a yellow, and here's a yellow. And I think the rest of them are non-yellow. So out of all the yellows, how many of them are hearts? It looks like 2 out of 4 of them are hearts. So the probability is 1/2. Don't really need a formula on that one. Assume 2 cards are drawn from a standard 52 card deck. This sounds really familiar. This is from the last test, I think. Find the following probabilities. Without replacement in part A, but it says find the probability of drawing 2 hearts. Okay, so I know 13 out of 52 are hearts. But without replacement means we throw the first one in the trash. There are 51 left. And there are only 12 hearts left. So that's the answer. One out of 17. And the only difference between that and part B is this one is with replacement, but it's still 2 hearts. By the way, I didn't multiply by 2 or worry about the order because a heart first and a heart second is the same thing as a heart first and a heart second. It doesn't matter if you switch around the ordering. Now with replacement, 13 out of 52 for the first one, but you put it right back in the deck, so it's still 13 out of 52 for the second one. So that sounds like 1 over 16. We're drawing a single card from a standard 52 card deck. Find the probability of getting a 4 given that it's not a face card. Okay. This one might actually be easier if we use the formula. Maybe. But that's the probability it's a 4 and a non-face divided by the probability that it's a non-face. And you might want to memorize this formula too for the test. Well, a 4 is automatically a non-face card, so the top is really just the same as the probability of getting a 4. And that is 4 out of 52, because there are 4 4s in the deck. Well, what about the non-face cards? Jack, Queen, King are the non-face cards. Well, there's actually 12 of them, because remember, you have 4 suits for each rank. So 12 out of 52. Actually, those are the face cards. I need to find the non-face cards. Well, 12 out of 52 are face cards, so that means 40 out of 52 are non-face cards. So those 52s cancel, and 4 out of 40 is 1/10. A certain game consists of rolling a single fair die. If a 4 or 5, this looks like an expected value one. If a 4 or 5 comes up, you win $6. Otherwise, you lose 3. Find the expected value of the game. Is it fair? Well, let's see. If you get a 4 or 5, you win $6. And the probability of that is 2 out of 6. But I don't think we have to pay to play this one. Otherwise, we lose. And 4 out of 6 times, we're going to lose. And when we do, we lose $3. And notice that that sums up to 0. So this is definitely a fair game because the expected value is 0. $700 chances are sold. 700 tickets total. $5 a piece. And there's one grand prize of $5.50. Two second prizes of $3.50. 5 third prizes of 100. First, calculate the expected value of the game. Well, we have 700 tickets. Only one of them is the grand prize. If we get the grand prize, we win $550. But we had to pay $5 to play. So subtract that from your winnings. Well, we have 2 second place prizes. And if we win second prize, we get $350. But subtract your $5 that you had to pay to play. 5 out of 700 of them are third prize winners. Win $100, but subtract the $5 that we had to pay to play. But don't forget that most of the time you're going to lose. There are only 8 winners, so there are 692 losers. And you don't win anything, you just lose your $5 in that case. I get negative $2.50 as your expected value. So on average, you lose $2.50 every time you play this lottery. But it is a lottery. They're raising money for a charity or something. A raffle. If the game is not fair, what would make it fair? Well, a fair price is the expected value plus the original price of the ticket. And the expected value is negative $2.50. The original price was $5, so if they charge $2.50, that'll make it fair. Find the mean, median, and mode for the following distribution. I'm so glad I showed you guys how to do this with the calculator before we stopped coming to class. Okay, now I'm going to do this on the TI-84. So the way you do it on that calculator, remember, is to hit Stat, choose Edit, clear out your old lists by highlighting the list and pressing Clear Enter. And in this case, we don't have a frequency list, we just have an L1. So put all your numbers in L1 if you have the TI-84. And then hit Stat, Calc, one variable stats, and make sure that the list says L1. There is no frequency list, so I'm just going to hit Calculate. And remember, the mean is the X bar symbol, so that's a 7 in this case. That's what my calculator gives me. And if you scroll down with the arrow, you should also be given the median. They also want that. It looks like that's 7 too. And the mode you have to decide for yourself. That's just the one that occurs the most frequently. Do we have any repeats? I see a couple of 7s there. Anything else? It almost looks like 7 is the only mode. All right. Now, if you wanted to do that on the other calculator, the Inspire, let me at least verbally review how to do that for you. And I believe in the classroom I've been mostly focusing on the scratch pad, But if you're in the Scratchpad, choose Calculate mode, and then hit Menu, Statistics, Stat Calculations, one variable stats, choose the number of lists to be 1, and when it says X1 list, put the data values between curly brackets separated by commas. And the curly brackets are right above the right parenthesis to the left of the 0. So I have to hit Control right parenthesis and then enter the data separated by commas. And then just leave the frequency list as a 1. Go down and press OK, and you should see the same mean, median, and mode. I guess in the case of the mode, you have to do that yourself. But I see 7 and 7 for the mean and the median. Well, let's go ahead and do 13. I guess what makes 13 a little bit different is we're given a frequency table. 2, 3, 4, 5, 6 are my X's. Alright, so, you know, on the TI-84, the only difference is let your X values be the L1 column, and let your frequency values be the L2 column. And you might have to tell the calculator to count L2 as the frequency list, depending on your calculator. So let me do that. I'm going to go to Stat, Edit, and let me enter the original data values, 2 through 6, in the first column. And I'll enter the frequencies in L2. And then I'm going to hit Stat, Calc, one variable stats. And my calculator lists something like this. It'll say list L1. It's already assuming the data values are in L1. And then it just says frequency list colon. So I have to tell the calculator to count L2 as my frequency list. I have to put this in there. So that's right above the 2. And then I can say calculate. You know, some calculators will just give you a one variable stats screen, and you have to actually put in L1 comma L2. So make sure that you do that if you have one of those calculators. You have to tell the calculator to count L2 as your frequency list. But when I do all that, I get 3.9 for the mean. And the standard deviation, remember that is this. It's SX. And my SX is 1.4. So let me at least verbally review how to do that on the Inspire 2. And I know we went over that in class, but let me go back to the data. So here's the data. Let's do it on the Inspire Scratchpad. So go to Calculate mode. You might have to clear out the stuff that's already on the screen by pressing Menu, Actions, Clear History. That'll clear the screen on the Scratchpad in Calculate mode. Now do basically what you did before. This is on the Inspire. Press Menu, Statistics, Stat Calculations, one variable stats, choose one list. And for X1 list, put the data values between curly brackets just like before, 2 through 6. Separate them by commas. But under frequency list, it's automatically set to 1. Delete the 1 and go ahead and put in these values in curly brackets separated by commas. Now obviously there is another way to do that using a document feature on your calculator, but that's the way I've been showing you guys how to do it with just the Scratchpad. So I don't want to do anything too radically different. But go down and press OK. I might put up a video which shows you how to use it with the documents maybe near the end of the semester, but press OK. And the X bar is still 3.9. It should be the same data. And the median is 4, and I think they also wanted the standard deviation. But I do get 1.4 for SX. The symbols are the same for both calculators. Suppose for a given month the mean daily closing price for stock A was 149.24, and the standard deviation was 14.8. For stock B, the mean daily closing price was $80.86, and the standard deviation was 8.7. So which one was more volatile? Stocks with greater coefficients of variation are considered more volatile. So let's try to remember the definition of coefficient of variation. It is the standard deviation as a percentage of the mean. So you can put the times 100 in there if you want to, but I just divide the S by the X bar and then change it to a percent. So let's calculate the coefficient of variation for A. It's 14.8 over 149.24, and we'll change that to a percentage. I get 9.9%. But let's do the other one. For the other one, I get 10.8%. So it sounds like stock B is more volatile, even though its standard deviation is smaller, because its standard deviation as a percentage of its mean is bigger. So actually stock B is more volatile. Assume that the amount of cornflakes in a box is normally distributed with a mean of 18 ounces. And I'll go ahead and use population mean notation. And a standard deviation of 0.3 ounces. Determine the percent of boxes that will contain between 17.55 ounces and 17.58 ounces of cornflakes. Alright, so you can do this with a calculator. I will verbally explain or review how to do it with both of them. I think we did do this in class before we had to stop going to class. But let me at least verbally remind you. So if you have the TI-84, take it out and make sure you do it with me here. But on these, go to distribution on the TI-84. And that's right above the variables key. So hit second variables and choose normal CDF. That's option 2. And your calculator will either display lower, upper, mu, and sigma, or it'll just give you a left parenthesis. But either way, you have to enter 4 numbers. The lower limit, which is 17.55. The upper limit, which is 17.58. You might have to put parentheses in between. I don't have to do that on my calculator. And then the mu and the standard deviation. So the third number is 18. The fourth number is 0.3. And then go ahead and press enter a couple of times. And I get this. Well, they actually want this as a percentage, so 1.39%. So, you know, they usually give you a table or something, but it's so much easier to do with this with a calculator. So let me verbally review with you how to do that with the other calculator. It's almost the same thing. And I usually like to do these on the scratch pad. So go to calculate mode, press menu, then statistics, but this time choose distributions, and then normal CDF. That's option 2 on this one too. And it's the same 4 numbers that you have to enter. It'll say lower bound, upper bound, mu, and sigma. So for lower bound, 17.55. Upper bound, 17.58. Mu is 18. And sigma is 0.3. Press enter a couple of times. And I get the same number, 1.39%. All right. You know, the picture actually kind of looks like this. This is kind of what I would do in class. I'd give you guys a bell-shaped curve. The mean is 18, and the standard deviation is 0.3. And we're looking for the ones between 17.55 and 17.58. So this is really the area that we're calculating, or as a percentage. But it's about 1.3% of the total. And remember, the total area is 1, or 100%. But the answer should be 1.39. So that should do it for video C.